look at exponential growth and decay. So this is an exponential equation. I guess we should define what the things are. Whenever you are building a graph, you're always going to have an x, and technically this stands for the y. So that's what these values are. There's going to be a whole bunch of values of x and y, like tons of coordinates all across it. So that's what these numbers deal with. These other two variables for an exponent are a little different. The a is typically the starting value. Okay, so typically where we start, whether they're giving you like a certain amount of money that you're investing, or there's so much bacteria and it's decaying or something like that, that's usually what the a stands for. It's also usually, unless there's a whole bunch of other variables involved, it also tends to be the y-intercept. Okay, intercept. So with that being said, b. B is where we get the difference of something that is growth or decay. And they give you little formulas where if b is greater than 1, then we're talking about growth, and if b is a value that is less than 1 but greater than 0, so anything less than 1, that is known as a decaying amount. So the equations are both the same. If we have growth, we use green for growth. So f at x is equal to a, and usually they'll split b. They'll say it's 1 plus whatever the growth rate is to the power of x, and that's what growth is. And for decay, we in red, decay is f at x is equal to a 1 minus whatever the rate is to the power of x. So the addition is going to give you a value that is greater than 1, and the subtraction is going to give you something that is less than 1. So let's say, I don't know, let's say we're growing by 50%. Well, that means the R value is 50%. So you have to convert our 50% to a decimal. So you would divide it by 100 and it would give you 0.5. So when we go to plug this in, our new formula with f at x is equal to, and let's say we start it with 100 of something. Okay, so we have 100. 1 plus 0.5. Okay, and when we simplify that, we get 100 times 1.5x. So 1.5 is greater than 1, which makes sense. It's a growth model. It's going up 50%. Let's say it's the complete opposite with decay. We start with 100, but it's decaying by 50%, so being cut in half every single time. We would start with 100, and then we have 1 subtract 0.5. Okay, and 1 subtract 0.5 is actually going to be 0.5. So now we have 0.5 to the power of x, and that's an x, there you go. These are our b values, right? This b value is less than 1, and this b value is greater than 1, hence why this is growth and this is decay. And if you look at them on something like this, let's say we have 100, I probably shouldn't use such a large value. There we go, 100. We said 1.5 to the power of x. It's kind of a very, very steep slope, but 100 is our y-intercept, and this is a growing model. So for it to be growing, what it means is going from left to right, it's heading upward. So it goes up and up and up. And if we don't use 100, we can kind of get maybe a little bit of a better view of something like this. We'll just say it's 1. So you'll see that it constantly goes upwards here. Our decay, we had 0.5. to the power of x, okay, and it's the complete opposite. I'll turn the red one off. From left to right, and our a value is 1 right now. If I made it 100, we zoomed out, the a value, the y-intercept would be 100, okay, but 1 is usually a little easier to look at. Our y-intercept is 1, and then from there it constantly gets smaller and smaller than 1, but never actually touches 0. It just gets smaller and smaller. So you can kind of play with these ideas. If I were to, let's call this b instead. We'll give it a slider. Okay. So anytime b is greater than 1, let's say 1 to 100. There you go. You can put it to play. Oh, we've got to turn it on. It's always going upwards. No matter what we do, this value is always up. Okay. Here, if I call this b, and we actually I don't want to call it b. Let's call it c. Slider for c, and we'll say it's between 0 and 1. We push play, you'll see that it's always heading downwards in this model, okay, no matter what, because it's between those two values. 0 gives us something a little non-existent, and then it comes back again, okay? So that's pretty much it. There's tons of other values that b could be, but anything greater than 1 is growth. Anything between 0 and 1 is decay. And that's kind of how you would build the formulas for the two things.